Let's take the 16th example from the topic Pythagoras theorem. In this question, triangle PQR is right angled at Q and points S and T, these are the points S and T, they trisect the side QR. Okay, and then we have to prove this. Okay, so again applying Pythagoras theorem, we have three triangles in which we can apply Pythagoras theorem. So let's take the first triangle P, triangle P, S and Q. T, and then we have at last PR. So we have three triangles. So we can write PS square is equal to PQ square plus QS square. Then we can write PT square is equal to QT square plus PQ square, and we can write PR square is equal to QR square plus PQ square. Also we are given that S and T trisects QR. So what we are going to do is we are going to substitute QS and QT. So QS we can write QS is equal to, QS is 1/3 of QR. Okay, QS is 1/3 because S and T trisects. These are three equal parts. So QS is the first part. So it is 1/3 of QR. And QT is equal to 2/3 of QR. So we'll substitute these value of QS and QT in equation 1 and 2. So substituting we get PS square is equal to PQ square plus QS, what will substitute, QR upon 3 whole square, and similarly PT square is equal to PQ square plus, instead of QT we'll substitute 2/3 QR whole square. And the third equation we have PR square is equal to QR square plus PQ square. So looking at all these three equations, this is equation 1, this is 2, and this is 3. We have PS in our final equation, we have PT and we have PR. And all this right hand side terms has to be eliminated. So how many variables we have? We have to eliminate PQ, we have to eliminate QR. Yeah, we have 3 equations and we have to eliminate two terms. So what we will do, we will subtract equation 1 and 2. So what we'll get? We'll get PS square minus PT square is equal to, we'll subtract, so PQ will get cancelled and we will be left with QR upon 3 whole square minus 2 by 3 QR whole square. And similarly we will subtract 2 and 3. So subtracting 2 and 3 will get PT square minus PR square is equal to, again PQ will get cancelled. We will be left with 2 by 3 QR whole square minus QR square. So now let this be our, again, equation A and this be equation B. And from these two equations, we only have to eliminate QR. Okay, so let's do this. So we'll substitute the value of QR in equation number B. Okay, in B we'll substitute. So we have PT square minus PR square is equal to QR square will take common and we are left with 2 by 3 minus 1. Yeah, this is a square. Okay, sorry, this is not 2 by 3, this is whole square, no? So this is 4 by 9 minus 1. Okay, and solving this, what we will get, we'll solve this as, again QR square common, then we are left with 1 by 9 minus 2 by 3 whole square, that is 4 by 9. Yeah, so this is QR square, this will be minus 3 upon 9, or this is equal to minus QR square upon 3, or QR square will be, so from here we can substitute the value of QR square in this equation, equation number B. So PT square minus PR square is equal to, QR square will be 3 times PT square minus PS square, bracket close, and here we are left with 9 and minus 5. Yeah, so again 1 3, so solving this again we will get PT square minus PR square is equal to, here we'll multiply it by 3 and here we'll have minus 5 PT square minus PS square. So again solving this we have 3 PT square minus 3 PR square is equal to minus 5 PT square plus 5 PS square. So again, solving this, we have 8 pt square is equal to 5 ps square plus 3 pr square. This is the final result which we have to prove. 8 pt square is equal to 5 ps square plus 3 pr square. Okay, so let's highlight the term, highlight the equation. This was our equation B and this was our equation A. And how we got B and A? By subtracting equation 1 and 2, we got equation number A, and then again subtracting equation 2 and 3, we got equation, then subtracting 2 and 3, we got the equation B. And the rest is very easy. We have only one variable QR, and we tried to eliminate QR from the two given equations and got our final result.